Hi, in this video we use Gaussian elimination to find the intersection of two planes or two lines. One thing to remember is that when we have two planes, the intersection line, if they intersect, the intersection line is basically the set of solutions of the system given by the general forms of the planes. Yes. So it means that to find the intersection point of two planes, we need to solve this system. Okay. So we have two planes. Let me see, I can do this completed. Yes. And they intersect at along some line. Yes, so we want to find what is that line, this line. Okay. We have to solve the system, so we need to solve the system. What system? Well, just put the general forms of these two together, and that's the system. X plus 2y minus z equals to 1, and x plus y minus 3z equals to negative. And we have to solve it. You can use any method you like. Here I will use Gaussian elimination. Step 1 is write the augmented matrix. And step 2, reduce it. Well, I choose this one to be my next leading entry, and then make everything below it 0. So to make everything below, which is there's only 1 here, negative 1 times negative 1 times the row with the leading one, and add it to row 2. So we basically need to subtract row 1 from row 2. This is what we have. So 1 minus 1, 0. 1 minus 2 is negative 1. And then negative 3 minus negative 1. This is negative 2. Negative 2 minus 1 is negative 3. So we're done with the first row. The second row, well, this is done. Yes, this is row in a row echelon form. That's the second step. The third step, well, write back the equation. So equation is x plus 2y minus z is equal to 1, minus y minus 2z equals to negative 3. Okay. So then you see that x and y are only two variables whose coefficients were leading entries, negative 1 here, 1 here. Now that means that the z, which doesn't have any coefficient, which was the leading entry, that means that z is going to be free variable, t. And while back substitution says that just write these variables with leading coefficient in terms of the other one. So this will be negative of negative 3 plus 2z. Yeah. And x is a 1 minus 2y plus z. We have to now write everything in terms of this variable t. Z is t, so back substitution starts from here. And then here 1 minus 2. Y is negative 3 plus 2 times t. Is it? No, the other way. It's 3 minus 2 times t. I'm taking from here, just putting there. And then z is t. And if I write all these things together, then x, y, z is the vectors z, x, y, z. So t is for z, y is 3 minus 2t. For x, you see we have 1 minus 6, this is negative 5. How many t's we have? There's 4 plus 5t. Very nice. I can rewrite this in a better way. X, y, z is equal to negative 5, 3, 0. I'm just separating the terms which have t in it. So it's 5, negative 2, and 1. Yeah. Then, very nice. What we do now, you see that this is equation for the line in the vector form. Yes. And if you notice, the original thing that we started working with, this is the equation for the line in the general form. What we did is we went from general form to vector form. From vector form to general form is much easier to go. Well, not very easy, but from general form to vector form, we basically need to solve the system of linear equations. So remark to turn general form of a line to a vector form, we need to solve the system. That's now, well, I could have asked this question completely different way. Find the vector form or a vector form for the line with this general form. Okay. So that's the first example. The second example about the intersection of the lines. So we have two lines. One is through point 1, negative 1, 2 and parallel to vector 1, 2, 2, and the other one is through point Q, 3, 3, 6 and parallel to vector negative 2, 3, 1. So what we do here is first write the equation for the lines. Yes, the first line is going to be x, y, z equals to 1, negative 1, 2 plus t 1, 2, 2. Well, if you write the parametric form, this is going to be x equal to 1 plus t, y is equal to negative 1 plus 2t, and z is equal to 2 plus 2t. This is line 1. Line 2, let me just write the final, the parametric form. X is 3 minus 2t, y is 3 plus 3t, and z is equal to 6 plus t. Yeah. So now, this is line 1, this is line 2. To find the intersection of line 1, line 2, and to check if they intersect or not at all, we have to set, so at the intersection point, the x components are going to be equal, the y components are going to be equal, and z components are going to be equal. Yes. So x of line 1 needs to be equal to x of line 2, y of line 1 equal to y of line 2, and z of line 1 equal to z of line 2. When you do that, you notice that, oh, both of them have parameter t. Do I need to solve it for t? This is very key point. Although we are using always the parameter t in these questions, but when it comes to the intersection, the parameter which parameterize one line must be different than the parameter use to parameterize the other one. So here, t I use for that one, I will use s for this one, 2s, 3s, just s, such that then we have the equation. So then we form the SLE, which is x of that equal to x of that. 1 plus t is equal to 3 minus 2s. Negative 1 plus 2t is equal to 3 plus 3s. And 2 plus 2t is equal to 6 plus s. Yeah. Now let's just write the equations in the standard or nice form. So this is t plus 2s is equal to 2. Then this is 2t minus 3s is equal to 4. And this guy is 2t minus s equals to 4. This is the system we have to solve, find s and t. But then the intersection point, if you know what is s, you just plug into one of these equations, well, in equation for L2, and get what is the intersection point. Okay, so we need to solve this equation, solve this. Which method you want to use? We are going to use Gaussian elimination. So we need to first write the augmented matrix. Well, 1, 2, 2, 2, negative 3, 4, 2, negative 1, 4. Yes. And okay, so then the next step is that turn it to row echelon form. Yes. So here I choose this one to be my leading entry. We have to kill this one, negative 2 times R1 plus R2. We have to kill this one. The same story goes for this one, R3. So R1 doesn't change. We stay, let's keep it the same. So first one, you multiply this negative, negative 4 minus 3 is negative 7. Negative 2 times 2 is 4. This is 0. And 2 times, okay, this is 0. Negative 2 times this guy will give me negative 4. And that is added there will be, this will be 0. Negative 4, this is negative 5. This is row echelon form now, or EF, because there's nothing else to do here. This guy is already not, oh no, it's not row echelon form, sorry. I have to do one more step. This is now my next, this is my next leading entry. I have to make this one 0. So for that, what we do is we multiply the row by, we want to kill this guy here. Choose it, move it, reduce the column below it, okay? So I don't need to move it. This is the good one. Now I want to make this guy 0. What can I do for that? Okay, one way to do this is you multiply row 1 by, first turn this guy to 1 by dividing that by negative 7, and then multiply it by the negative of this one. This added to row, oh, this was row 2, added to row 3. This is 1, 2, 2, 0, negative 7. We are not changing row 2. Row 3 will be, you see, negative 7 times 5 over negative 7 will be 5. Added to negative 5 is 0. That is. This is now row echelon form. Yeah. Now that we have row echelon form, we can go ahead. This step 2 is done. Step 3 is write back the equation. So this is x plus, oh, not x, t. T plus 2s equals equals to 2. Negative 7s is equal to 0. And the last one is, okay, just forget that. Then start backward. This is s equal to 0. T is equal to minus 2s. And then plug in that one. 2 times 0. This is 2. Very nice. That means that the solutions are 2 and 0. This is not the intersection point. This says just what would be the parameters which for the intersection point. So you pick one of these. Let me pick the S0 and put it back into the equation with the parameter 0. So the intersection point is when you plug in s in that equation equal to 0. So it will be 3, 3, 6. Okay, I can do this. 3 minus 2 times 0, 3 plus 3 times 0, and 6 plus s2. This gives me 3, 3, 6. This is the point of the intersection for this, for these two lines. Okay.